All right, so we know that the adjacent side and the opposite side and the hypotenuse are all proportional. They all have the same ratio. So this really helps us because if we have two right triangles with theta as an angle are similar, then the ratios, we can pick any two sides and put them in a ratio together. They're always going to be equal to the same value. So if I took the opposite side, the length of the opposite side, and divided it by the length of the hypotenuse, that's what we define as the sine of theta. Sine of theta is that ratio. It's the length of the opposite leg divided by the length of the hypotenuse. Well, every time we write sine of theta, we don't write all this out, so we shorthand it a little bit. Sine is sin. You always have your angle here, theta. And then we write, even though I train many of you to always define your variables as quantitative, we now say opposite over hypotenuse. Okay, so you will memorize all of these definitions because you'll use them over and over again for the rest of the semester. So opposite divided by hypotenuse is the same in both of these triangles. Doesn't matter the size. It's always based on the angle theta, the results of these two ratios. Not dependent on how big the triangle is or how small. But if they have the same angle theta, those ratios are identical. We define another trig ratio, a trigonometric ratio, as the side adjacent, the leg that's adjacent to theta divided by the hypotenuse. That's called cosine of theta. So that would be adjacent here divided by the length of the hypotenuse. That's your second trig function. Again, shorthand cos, theta. And then finally, the tangent of theta is the opposite side divided by the adjacent side. It's the ratio of your opposite leg divided by your adjacent leg. Again, the shorthand for tangent is tan, theta, opposite over adjacent. So you notice I have in bold here, the trig ratios of theta depend only on the size of the angle theta and not on the size of the triangle. So let's take a look at this right triangle below and let's figure out what the three trig functions are for the angle theta. So here you are down here at angle theta, and we want to find sine of theta, cosine of theta, and we also want to find tangent of theta. All right, so sine of theta is the opposite side, 5 divided by the hypotenuse, 13. How about cosine of theta? Anybody? Cosine of theta? Yeah, Bella? Right, length of the adjacent side divided by the length of the hypotenuse. And then finally tangent. 5 divided by 12, right. So I just want to show you something. Tangent theta is sine theta divided by cosine theta. But look what happens. Sine theta is 5/13 and cosine theta is 12/13. When you end up dividing by 12/13, you multiply by the reciprocal. So your hypotenuse, because you have the same denominators, they cancel and you just get opposite over adjacent. But tangent theta is sine divided by cosine. But we just say opposite over adjacent because the hypotenuse is the same in both. All right, any questions on those three trig functions? Okay, so now let's find the lengths of the sides of the triangle below, given the adjacent side is 10 inches. So the first thing you have to do is make sure you identify what your angle is. Your angle is 25 degrees. All right, so here's my angle, and I want to find the adjacent side. I've labeled it for you. That would be 10. And when you put this into your calculator, let's see, I'll take the old regular old-fashioned calculator, the 83. The first thing you have to, I don't know about the TIs that you all have. Do you have, can you put in degrees there? I don't have one of those visually, but if you have a TI, all you have to do is go to the mode, and you see it says right now it's in radian. We'll be there in a few days, radians, but we got to go over and make sure we're in degrees. So when we put the number in for the angle, the measure of the angle, it knows it's degrees. All right. Now let me see your other calculators that I've asked you to get, just the regular old TI 30X's or whatever. Anybody got one of those? I see a lot of graphing calculators, Casio. Okay. So these, let's see, I would assume it's similar. I should have checked these before coming in here. Do you know how to put this in degrees? Oh, is it? Oh, yeah. So if it says on the bottom in little teeny font like 2, says degree. Oh, same thing? Okay. It's under mode. Okay, good. All right. So that's the first thing you got to make sure is that your calculator is in degrees, or you won't get the correct answer. Okay, so let's quit that. So now let's find each of these. Let's find the lengths of the sides of the triangle. So how are we going to find the length of this side? Well, this is the opposite side. If we knew the opposite over the hypotenuse, we would have no work to do. So all we have is the adjacent. So you have to think in your mind, what trig functions have adjacent in it? Well, cosine has adjacent over hypotenuse, right? So, but I'm not trying to find the hypotenuse, I'm trying to find the opposite. So which trig function deals with the opposite side and the adjacent side? Let's see. Let's go back. Sine deals with opposite and hypotenuse. Right. So we need the trig function, the tangent, right? So we write this. The tangent of 25 degrees is equal to the opposite side, let's call that A over the adjacent side, which we happen to know. Right? So this is an easy equation to solve because I have only one unknown and everything else is there. I just solved this for A. What do I do to solve for A? Multiply both sides by 10, or again, just getting you used to the good old proportion idea, because we're so weak with that. Cross products are always equal in a proportion. So A is equal to 10 times the tangent of 25 degrees. So if you don't see it as a proportion, you can say multiply both sides by 10. It's okay as well, because the coefficient of A here is 1 over 10. So you're just multiplying by the reciprocal. All right, so you plug that into your handy-dandy calculator. And this is the exact answer. So if I ask you for an exact answer, that's what you would write. If I then say approximate it, you would put it into your calculator and you would say 10 times the tangent. You find your tangent, and because you're in degree mode, 25 degrees is 4.66 approximately. Okay, so this is an estimate or an approximate answer. So make sure you're always looking at what the instructions ask you to do. So now you have that. And I'm going to write this in the exact answer here. I always do put all of these inputs in parentheses. That's just my habit. It's called the argument. Now I haven't found the length of the hypotenuse. So how do I do that? Well, the hypotenuse is used in a couple of those trig ratios, right? But I have the adjacent. The adjacent over the hypotenuse is called the cosine. So to find the hypotenuse, we'll call that C. I take the cosine of 25 degrees, which is the adjacent over the hypotenuse. And so similarly, to find C, I multiply both sides by c, and then divide by the cosine of 25 degrees. If that was too fast or you need to see that done, I will show you. It's okay. Does everybody see how I got that? Yes? No? Anybody have a question? It's okay. Bella? Okay. So I multiply both sides first by c, Bella. All right. That's my first step. Now you get it? Okay. Okay. Don't hesitate to ask. So now I throw that into, that is the exact answer for C. If I want an approximate, I put my little squiggles, and then I say, okay, 10 divided by the cosine of 25 degrees is approximately 11.03 or 04, 11.04 up to 2 decimal places. So if you have an angle and a side, you can find everything else. If you have two sides, you can find all of your trig ratios. Because notice, let's go back here. Something I neglected to say, but I guess I was assuming everybody did their preview. That if you didn't know this side was 13, how would you find it? Pythagorean theorem. Or if you knew this side and this side, you'd use a Pythagorean theorem. So remember, 5 squared plus 12 squared, the square of the legs is equal to the hypotenuse squared. So you can always, if you have two sides, you can always find the third side. And then you can find your trig ratios. If you have one of your angles, other than your right angle, of course, and one side, then you can find them with your calculator. All right, important. For most angles, the trig functions are ugly numbers, really ugly, like you just saw. However, we have 3 very special angles, 30 degrees, 45 degrees, and 90 degrees. And you should, I'm going to change should to must. $60. I said 90. Thank you. See, you're even editing my talk. That's great. I love having Hazel back. I wonder if the one in one of them I said, Hazel, sorry, I forgot to record the middle part. And that might have been the one that didn't have sound. I don't know. Yeah, anyway. All right. So how do we think about this? Literally, folks, when I've been away from trigonometry for a long time, I literally think back to how did I get these trig functions for these special angles? And this is what I conjure up in my mind. I conjure up a square. This is how I start. Because you know what? Life, you know, if you forget, I conjure up a unit square. A unit square has all sides 1, yeah? What's the angles in a square? 90. So I cut my square in half, like that. And I remove a half, very gently, surgical here. This is 90. What's these angles here going to be? 45. See, I don't have to memorize because if I forget, I have a picture to call back. Now, if I have a square with size, length of this side 1 and length of this side 1, this has to be what? Almost square root of 2. In general, in case you ever forget, if you have a square of length s, the hypotenuse, or the diagonal, because it's not a triangle, is s times the square root of 2, always. So given that we have sides 1 times the square root of 2 is square root of 2. 1 square plus 1 square is 2, c square equals 2, c equals square root of 2. So there's no work to really be done here. When you have a 45-degree triangle, right triangle, 45, 45, we call this an isosceles. I know some people are weak with geometry. We don't teach geometry here. Isosceles means your two legs are the same size. You have two equal angles and two lengths that are the same. Right? So for an isosceles triangle, we're working with this middle column right here. So what would be the sine of 45 degrees? Does it matter which 45 degrees I pick? No. So let's go down here. So the sine is opposite over hypotenuse, 1 over the square root of 2. 1 over the square root of 2. Now there's a little thing in math. We don't like having radicals in the denominator. So we use a little bit of arithmetic to what we call rationalize the denominator. We want a rational number in the denominator. We don't want an irrational number. Denominator. All right, there we go. We want to rationalize the denominator. So how do I get rid of the square root of 2? I multiply it by itself. Square root of 2 times square root of 2 gives me a 2. But whatever I do to the denominator, I must do to the numerator, because I'm only allowed to multiply by some fancy form of 1. So this is square root of 2 over 2. And that's how we'll write it for the rest of the period, the rest of the semester. Square root of 2 over 2. So this is square root of 2 over 2. Cosine, adjacent over hypotenuse, same exact thing. 1 over the square root of 2 equals square root of 2 over 2. Do you like 45-degree angles? Because cosine and sine are exactly the same. What's going to happen when I divide sine by cosine to get my tangent? Or opposite over adjacent? What will be my answer? 1, right? Because they're exactly the same. 1 divided by 1, square root of 2 over 2 divided by square root of 2 over 2 is 1. All right. So we've got a third of what you have to memorize done. If you forget, remember, how did we start? With a square, and we cut the square in half, a unit square of length 1, we found the diagonal. You can recreate that for yourself. Now here, notice I've got this dotted thing in here, because this is how you remember your other angles, 30 degrees and 60 degrees. You start with an equilateral triangle. Equilateral means all sides have the same length and all angles are the same. So if this side is 2, this side is 2, and this bottom side is 2, which means that's also 1. We got 1 and 1 to make 2. Notice this height bisects the side of length 2. So we're looking right now at, we forget about that triangle. It's going to be exactly the same as this one, kind of upside down a little bit, rotated. So we got a 30 degree here, a 60 degree here. We got a 2 here, and because we're only looking at half of this equilateral triangle, our base is 1. So we've got to find the height. So let's call that A. Let's find length A. So length A is going to be 2 square take away 1 square equals A square. Because your Pythagorean theorem looks like this when you're solving for C, and if you solve for A or B, you do C squared minus B squared equals A squared, or C squared minus A squared equals B squared. So 2 squared is 4, 1 squared is 1, so A squared is equal to 3. So since we're dealing with just positive square roots here and not negative, A is the square root of 3. There we go. So now we've got our 3 sides of our right triangle. Okay. Notice that the square root of 3 is bigger than 1. Square root of 3 is a little bit bigger than 1. And again, square root of 3 is opposite the 60-degree angle, so it has to be a bigger length than the length opposite the 30-degree angle. And your biggest side here is 2 because it's opposite the 90-degree angle. All right, let's do our ratios. Let's do 30 degrees first. Side opposite over hypotenuse is 1 over 2. Let me see if I can get that to come downstairs so I'm going to cut that out here. I haven't played with this for a while. Where is my camera? Oh, my camera's not on here. Is that it? Nope. Tools. I don't see camera. Oh dear. All right. Do I have Snagit on here? No, I don't have Snagit. I want to cut that out. I usually have my camera. Where is it? Okay. Let's not record all of this. We'll find it in a second. Ah, hit the wrong thing. All right. Tools. Let's see. Maybe it's here. Nope. Maybe it's here. Nope. It's not there. Where's my help? Help! I don't have, here it is. Never mind. All right, can you just copy this down here so you can refer to it? Or maybe you can see it on your paper, I can't, okay. All right, cosine of 30 degrees. Cosine, the angle adjacent to it is square root of 3 over the hypotenuse, which is 2. And the tangent is sine divided by cosine, or opposite over adjacent. The 2's cancel, you get 1 over the square root of 3. And what are we going to do with that? Multiply it by root 3 over root 3, right? To rationalize. Square root of 3 over 3. Now, let's see what's going to happen with 60 degrees. Here's 60 down here. The sine of 60 is the opposite, square root of 3 divided by 2. And I'm going to pull out this right here, this piece for a minute. Just call it square root of 2 over 2, square root of 2 over 2. You'll see why in a minute. Pull that out. And what's the cosine for 60? Adjacent 1 over 2. Oh, they just swapped places. Look at that. Isn't that interesting? The sine of 30 is the same as the cosine of 60. The cosine of 30 is the same as the sine of 60. I wonder why that works. All right. And the tangent of 60 is sine divided by cosine, or the side opposite the 60-degree angle, which is square root of 3 over the adjacent 1. The 2's cancel, we just get square root of 3. So these 9 numbers have to be in your brain. You should sit down and redo this table over and over again until you have it. There's not a lot of numbers to memorize if you really look at it. It's just a few. All right, so one little trick I want to show you. Do you all agree that I can write 1/2 as the square root of 1 over 2? Square root of 1 is 1, right? So look what happens with sine as you go 30, 45, and 60. Square root of 1, square root of 2, square root of 3. Kind of cool. What about cosine? Square root of 3, square root of 2, square root of 1. Just a little handy dandy memory thing. It helps you to memorize it. All right. All right, so let's see. Are we done? No, we have an application. Okay. So I want to read this for me. Jackson, please. We missed you so dearly the other day.
Horizontal line and a line of sight to an object that is either above angle of elevation, angle of depression, or horizontal line.
Right. Okay. So if this is where you're looking, right here, you imagine this horizontal line. If you're looking up to the plane, because you're looking above, this is called the angle. This is your line of sight. You're the observer in this window, and you're looking at this airplane, waving goodbye to your honey, and here's your angle of elevation. Okay. Then down here is your other honey. No, I'm teasing. Driving away in the car, okay, and you're looking down to the car. You still have this horizontal, And this is, am I still recording? Oh boy, I'm in trouble. Angle of depression, okay? So often we'll be using, maybe I'm not recording. Oh, good. Phew. Oh, I am recording. Oh, okay. It's all right. It's only all of you if you listen. All right. All right. So, yeah. All right. So some applications you will be reading in your homework will involve angle of elevation. Some will involve angle of depression. You can always refer back to this for help. Okay. So, and I got this from the Blitzer pre-calculus book. I thought it was a really nice visual. Okay, so here we go. I'm walking away from the east building. We used to go out in the old days. I had a friend who taught here, and he was an engineer, and we used to use a transit, and we would go out and measure stuff in pre-calc. We don't do that anymore, but anyway. So I'm walking away from the east building. Does that look like the east building? Kind of. All right, I'm walking away, and I'm 100 feet away from the east building. So that's my horizontal, 100 feet away. And I use a transit to determine the angle of inclination. Oop, I just threw a new word on you, did I? Instead of angle of elevation, angle of inclination is the same, elevation. It's just another name for elevation. So I'm looking up to the top of the building. So I'm looking up to the top of the east building, and that is 38 degrees, but it's not from the ground. I can't say I'm 5.5 feet tall. I just use this because I'm not 5.5, but I'm holding my transit, okay, above my head, 5.5 feet, and I'm looking through it, okay? So I got to start this up a little bit. So let's say right here. So this is 5.5 feet, 5.5 feet. And that angle, so now I can have my horizontal line right here, which is still 100 feet, right? And that angle of elevation or inclination is 38 degrees right there. All right. So I want to find the height, this entire length here. So I know right now that this green height is 5.5 feet. So I have to find the length of that side right there. It's the side opposite, yeah, my 38 degree, let's call that A. So I have to find A, and when I find A, I add to it 5.5 feet, because that's the whole height of the building. All right, so how do I get going here? Well, I put 100 feet in here, and I need to find A. A is the opposite, and I have the adjacent. So the trig function, the trig ratio that's going to help me here is the tangent. The tangent of 38 degrees is my opposite over my adjacent. So I throw into my calculator the tangent of 38 degrees is the opposite over 100. So to solve for A, I multiply both sides by 100. Okay, that's the exact length, but given that I'm answering a question here, I want it to the nearest tenth of a foot. I want my answer to the nearest tenth of a foot. So I open up my calculator, I put in tangent of 38 degrees. I turn it on first, clear it out. Tangent of 38 times 10 is 7.812856, so I want 7.8. So the height from, oh, yes, thank you. I was going to say that's a small building. Times 100, thank you. So it's 78.1. A is approximately 78.1. Now I add to that, right, the 5.5 feet, and I get 83.6 feet tall. There's all kinds of problems like this with shadows, like my shadow versus the flag post shadow, and your two similar triangles. There's all kinds of typical kind of right triangle trig problems that you can use. Okay. So you just need to work with these ratios so that you don't even have to think about them anymore. Note that at the moment, our definitions for sine, cosine, and tangent have a domain of, well, we're always talking about sine, cosine, and tangent of these two angles. What do those two angles add up to? 90. So one has to be, both angles have to be less than 90. Do we know what we call those cute little angles? Acute, yeah. So, so our angle theta is strictly less than 90 degrees and greater than 0 degrees. They're always acute angles, and that's just for right now, at the moment, that's what we're dealing with. All right, so if you've never heard this before, I don't know, I always think of Pocahontas when I look at this. I don't know. There's a nice little mnemonic device, and I always say it wrong because of my Boston accent, so I'm going to try to say it right. SOHCAHTOA. I always said SOHCAHTOA. No, I didn't say that. SOHCAHTOA. S stands for sine. OH is opposite over hypotenuse. C for cosine, adjacent over hypotenuse. T for tangent, opposite over adjacent. So it's just a little mnemonic device to help you. I've seen, was it your book or another book? Something about hogs doing something. I mean, it was a totally different mnemonic. So you can invent your own mnemonic if you want. It's kind of, I'll show you later on when we get into circular trig. I had my class way back. It was in the 90s. I had them do a new mnemonic for it. And this one guy named Doug came in literally with 100 different phrases. 100. So, and actually one of his won, and that's what the class used. So anyway, that's right triangle trig. Have fun. Oh, I got to do someone else right here. One more thing. All right. I'm tired of listening to myself. Anybody want to read this? You already read. All right, go ahead then. All right, so notice here, if we're looking at theta, the side opposite is here. If we're looking at phi, the side opposite is here. So notice how I've labeled these differently depending on the angle. So go ahead.
Generally, you pick an angle for the opposite.
The opposite side is the side furthest away from the angle, not the hypotenuse, right? Okay.
In English, it's nice to put a touchy. You can have take the side that on the hypotenuse next to the touchy.
All right, there you go. You're off to the races now with your lesson activity. Yes, Shane? Yep. Yes, it's your choice. Yeah. If they're not identified as being a certain degree, yeah. Yeah. Any other questions for you? Move into lesson activity land. All right.